Hey everyone, Chang here and welcome to my channel. Now, we know that cavemen in the past are all extinct. That's a no-brainer. My theory on why they're extinct is because they encountered problems like this. Now, this is a ratio problem. Today we're going to be talking about ratio and proportion. Ratio actually has two types, right? There's the first type of ratio, and I'm going to use this as an example and explain the first and the second type of ratio. So the first type of ratio is basically ratio in terms of another. In terms of another. Now, these type of ratio, normally you would see the notation is that they're going to have at least two numbers, it might be more, and they're separated by colons. So, for example, the ratio of male to female in a classroom is 3 to 4, meaning that 3 colon 4. There you go. This is the notation of the first type of ratio. It's saying that whatever is stated first in this situation, the male, right, that's the number. Compared to female, the second number. And then if there's a third one, there's going to be another colon and a third number and another colon, fourth number, so on and so forth. That's the first type of ratio. So when you see colons like this, you're most likely talking about the first type of ratio. The second type of ratio is the one that actually we like a little more, right? The ratio in terms of whole. In terms of whole. Now, what do I mean by that? Well, rather than comparing one number to the other, so in this case male to female, you're going to say male in terms of a group in the classroom, right? It might not be the whole classroom, but at least a group in the classroom. So we know that if in a group of 7, right, because of this particular ratio, we know that there's going to be 3 males. Let's make it thicker so you guys can see it. 3 over 7. The top part is one of the, I guess you could say, factor or the variable, and the bottom one is what we call the whole, right? In terms of the group, total is going to be 3 plus 4 is 7. So 3 out of 7 is going to be male, so you guys can guess. 4 out of 7, which is the other one, is female in relation to a group in the classroom, right? Now, these are ratio. Proportions are very related, interrelated, I guess you could say, to ratio, because usually when you have ratio problem, they're going to ask you for proportion as well. Now, what is proportion? Proportion is a comparison between two different ratio. And it's not saying one is bigger than the other. It's actually, they are technically equal. If you simplify one, you will get the other. So, for example, 3 over 7. That's just assuming that a group has 7 students, so 3 would be male. If I say, however, that a group has 14 students, just by this ratio, instead of 3 males, there should technically be 6, right? These two numbers are proportional because this one, if you simplify it, technically it's just that, right? Same with this one. If I were to write 14 in a group, in terms of female, by this ratio, should be 8. If I were to simplify it, these should be the same. And then, of course, we can keep going on and on. If I say the group has 21, well, by this sort of ratio right here, we know that instead of 3, there should be what? 9 males. And if I say 21 again, female, it's going to be 12. Plain and simple. And then you simplify it, they're going to be the same. That's the two different types of ratio and the proportion in relation to these ratio. So let's work on some problems. Alright, so in the beginning I mentioned that there are certain problems, special type of problem where you can sort of finagle and reason your way through it. This is one of those problems. In a bag of candy, there are white chocolate, milk chocolate, and dark chocolate. The ratio is 2 to 3 to 4, meaning for every 2 right here, white chocolate, there's going to be 3 milk chocolate and 4 dark chocolate. The bag contains 108 candies. How many milk chocolates are there? Well, first and foremost, when we look at this, my preference is always, instead of ratio in terms of another, I'd rather just see it in terms of an entire group. Well, we're looking for milk chocolate. So which one is milk chocolate? The first one, the first number is white chocolate. Second number is milk chocolate. And third number is dark chocolate. So the second number is milk chocolate. So I'm going to just write 3 right here because that's the milk chocolate. And assuming, let's just say this is one entire group. So in an entire group, it's going to be 2 plus 3 plus 4. What is that? That's 9. So in a group of 9, 3 is going to be milk chocolate. Cool. Well, guess what? We have 108 candies total. Well, we don't want just one group of 9. We want to figure out how many groups of 9 are there to get us a total of 108. Well, hopefully from our experience, we know that some number times 9 is going to be 108, and that's going to be 12, right? So we're going to multiply the bottom by 12, meaning that there's 12 groups of 9. Well, if there's 12 groups of 9, that means there should be in each of those 12 groups 3 milk chocolate. So we're going to multiply this one by 12 as well. Well, in that case, the bottom is going to be a group of 108 candy, which is what we want. At the top, it's going to be 3 times 12, which is 36. So from here, we know immediately that the number of milk chocolate in that bag of candy is 36. Just like that. And if not, another way we can go about it, which is more like sort of brute force in terms of whether you're persistent or not, right? We can continue doing this. Well, instead of 2, 3, 4, because when we add together is 9, we can increase it or double it. What do we get? We get 4, 6, 8, and then we add them together, that's 18, and then we can keep on going. Well, what happens if I double this, right? I have 8, 12, 16, and then you add these guys together, and you keep on going until hopefully you get 108. Right? And then you increase, decrease, double, half it, whatever, however you want to go about it. But of course, this is a little quicker. Now, the actual way of solving this, or not really formula, but more of the sort of common or expected way, is basically cross multiplication. What you do in terms of cross multiplication is you always end up relating two different ratio and then you cross multiply it. So let's look at this for example. So remember that I already solved it using sort of a reasoning, trying to break it into groups and understanding it this way. Instead of that, let's just go back with the 3, right? It's milk chocolate. So I'm just gonna MC right here as milk chocolate. And then we said 9 because we added all those guys together to figure out, and that's the whole. Okay, whole bag. Or whole group at least. All right, the next one is we're gonna have, well, we want 108 total. So that's our whole. What we wanna find is our milk chocolate. We don't know what that is. I'm gonna put X right here. Okay, probably not X because cross multiply is gonna make it look a little weird. What should I, let's do Y then. All right, now, here's how you would normally do it. You make sure that the top and bottom are related, or not equal, but yeah, related in terms of the units. This is milk chocolate, so this top must be milk chocolate. This is the whole group, right? This must be the whole group. So what you do then, because they're supposed to be proportional, you cross multiply it. So basically 3 is gonna multiply by 108, and 9 is gonna multiply by Y. So we're gonna do 3 times 108 equals 9 times Y. There it is. And then what you're going to do is you're going to solve for Y. Once you solve for Y, that's the exact number we need. Well, in this case, we're just going to divide by 9 on both sides so that we get Y by itself. Okay, so what is that? Well, we can simplify it. 108 divided by 9 is what? 12. So it's going to be 3 times 12 equals Y. So 36 equals Y. And just like that, since Y is 36, that means it's going to be 36 milk chocolate. This method, again, is called the cross multiplication. Now, this next problem is more typical of the kind of problems you would see in a homework or tests of any sort. And this type of problem actually makes it a little difficult to try to just reason your way out just by trying to compare and then sort of figure out how many you need. The reason for that is because the number is not really pretty, right? I'm going to show you why in a second. A steak recipe requires 5 teaspoons of pepper for every 3 teaspoons of salt. You add 4 teaspoons of pepper. How many teaspoons of salt should you add? Now, when you use the cross multiplication method, the proportion method, right? What you're going to do is, what we're talking about, teaspoon of pepper in relation to teaspoon of salt. Well, let's just say we have 5, and they're all teaspoons, so I'm just say pepper right here, right? Pep, and the bottom we're gonna have 3. And we're just gonna say salt. I'm gonna spell it all the way. Don't be too lazy, right? So for 5 teaspoons of pepper, we need 3 teaspoons of salt. Now, if we add 4 teaspoons of pepper again, once again, by the cross multiplication method, they have to be, well, since this is on top, it's gonna be on top as well. 4, and there's gonna be pep right here. And the bottom is what we're looking for, right? We're looking for, let's just use Y again, salt. We don't know how many teaspoons of salt we want, and hopefully this will tell us. So cross multiplication, there it is. Okay, so it's going to be 5y equals 3 times 4. 3 times 4. Well, in this case, it's just going to be 5y equals 12. We want to solve for y. We divide by 5 on both sides. This 5 cancels. Y equals 12 over 5, or what is that? 2 and 2 over 5. So we have basically a mixed fraction or an improper fraction, whichever one you want, right? It's a lot harder to try to reason it out and try to figure out the improper fraction. Now, this is a pretty nice looking fraction, if you can define fractions as nice looking, right? This is the more nice looking one. If you have one where it's a crazy number on top and a crazy number on bottom, just trying to reason it out, not that great. Cross multiplication will save you so much more time. And it pains me to admit that, but that's usually the case. Alright, so for this next problem, yeah, you can reason it out actually. You really can. It's not nearly as bad, but of course you can also do cross multiplication and then it'll solve it quicker, I would say. So, a treasure map has a scale factor of 1 over 8 inch for every feet. If the length of the map is 14 inch, how many real distance must you travel? Well, in this case, we can actually figure this out, right? 1 over 8 inch for every feet. So, if I wanted 1 inch, let's see how many feet is that. Well, 1 over 8, 2 over 8 is 2 feet. Well, 3 over 8 is 3 feet, so on and so forth. We realize that 1 inch is equal to 8 feet. Right? Well, if that's the case and we want 14 of them, right? Well, if we know 2 inch, that's going to be what? 16 feet, 3 inches, what? 24 feet, so on and so forth. If we multiply this one by 14, right, go all the way down to 14 inch. Basically, we have that it's going to be, was that 112 feet, I believe? Hopefully, I did this math correctly. Too quickly for me to double check, but yes, 112 feet. And then that's it, right? How many distance must you travel? There it is. So that's pretty quick. But if you want to do cross multiplication, this is what we would do, right? We would have 1 over 8, and this is going to be inches, all over, and this one we can say 1 feet. And of course you can flip it around as well. That's entirely fine. Just make sure that whatever you put here has to match in terms of the position. So since I put inch on top, right, 14, it's going to be an inch on top as well. This one, I'm trying to find how many feet there are. So in that case, it's going to be question mark feet or just y feet. Right? And then you cross multiply. Bam, bam. Okay, cool. That means 14 equals 1 over 8y. You multiply by 8 because it's 1 over 8 on both sides. This goes away, so you have y equals 14 times 8, and that once again is just going to be y equals 112, and we know that that's in terms of feet, so it's going to be 112 feet. So in comparison, yes, this is doable, and then of course if you can reason through it pretty quickly, that's a pretty quick way of getting it. And this one is a surefire way, as long as you remember same position, top and bottom, and then you cross multiply, solve for the missing variable, whatever that is, and then that's the one you're looking for. Alright, so there you have it. This one topic is one that I begrudgingly accept, that it's just so much more beneficial to remember cross multiplication instead of trying to reason it out. Reasoning it out is great. If you have extra time and it happens to be a nice problem, cross your fingers, right, you can reason it out. If it happens to be some very ugly decimal or ugly fraction, then it's just tough. So the best thing to do is to remember the cross multiplication method. So in summary, we have 2 different types of ratio. We have the Ratio in terms of another. Remember that this is usually the one that's separated by colons. And the numbers are in order of the subject that it's talking about, right? So the first number is going to be the first subject, second number, second subject, and it can go on and on, 3, 4, 5, right? The second type of ratio is the one that we love more. It's the one in terms of a whole, right? So you have that one subject in terms of the entire group. And then from there, we work with proportion. Proportion, again, even though it's sort of a comparison between two ratio, technically they are equal, right? It's just that one, if you simplify it, can become the other. And then that developed the whole cross multiplication. Remember, for cross multiplication, it's fairly simple. Whatever you put in one position, you make sure that it's the same position on the other. If you put inch on the top of the fraction, then on the other side, inch must be on top. If you put feet on top, feet must be on top. If you put milk chocolate on the bottom, milk chocolate must be on the bottom, right? And after that, you just cross multiply them, and then you solve for the missing variable. And with that, you have the answer to your problem right there. Hopefully this is helpful, even though it's painful for me. Thank you for watching this video. See you in the next one.